right? Although I just would have posted first period's recording, which is pretty decent. But okay, so again, I need to, in order to find the volume of my solid, I need to integrate the area of the cross section. So A of x, that's what that represents, is area of cross section. So that's what we're going to do. Okay. All right, here we go. Now, the way that we build our solids is going to be much different than the problems that you guys saw. Okay. A lot of the problems revolve around us building a solid based on a flat surface. So we're going to have like one flat surface, and then we're going to build a solid off of that flat surface, okay? So we're going to say the base of a solid lies on the circle x squared plus y squared equals 16. The cross-section perpendicular to the x-axis are squares. Find the volume of the solid, okay? So Rasika, the big idea that I just reviewed is that if we want to find the volume of something, you just need to integrate the area of the cross-section. All the cross-sections you guys did for homework were circles. So we did pi r squared every time, right? But now our cross-sections are going to be something other than circles, okay? All right, so here's what this wants you to do. It says we're going to build our solids differently this time. We're building this one on a circle. So we're going to have a flat circle on one of the sides of our solid. Okay, so we're going to build that on our xy axis right now. So let's just draw a circle with a radius of what? 4. Okay, so 1, 2, 3, 4. All right, well, the start of that circle looks pretty good. Not much better, but okay, here's our circle, okay? Now, it's a little tough to see that, like, based on what it says in the instructions, but it says the cross sections perpendicular to the x-axis are squares. What that means is we would take the length at any x value, let's just say whatever, this x value right here, it doesn't really matter. But if I take this length right here, this is the dimension, that's one of my side lengths of a square, okay? So that means that coming off of that flat surface is going to be a square, okay? And whatever length this is here, we would take that same length and it would go up that same distance. And it would make a square that comes off of your circle. And it would do that everywhere on the circle. So like obviously if we pick this x value, then we're going to get a bigger square because the side of that square then grew. And it's going to look something like that. Now it's really, really hard for me to draw that on my graph. So that's why I have models for you guys. So again, the bottom of this is your circle. Okay, here's your circle, okay? And then coming off the bottom of this circle, at any one of those cross sections are squares. Cody, I need you awake for this, man. I need you here.
Yeah, Cody.
So you look at it and call you out too, Max. The flat part of this is a circle, okay? And then we're building squares that come off that circle to give you something that looks like this, okay? So if you slice down on it, you have a square is your cross section, okay? Let me pass this around so you guys can look at it. But like, so essentially like this flat circle is right there, and then coming off of it is a bunch of squares. Does that kind of make sense? It's wild to envision. It really is. So pass that around so you can get a good idea of what that looks like. But that's what we're doing. I don't think I have anyone that's like alive. I have, what do you need it for, your iPad? Yeah, I got nothing for you, I'm sorry. Oh, she's charged. Very illegal.
It makes sense when you because the squares get smaller,
Yeah, and mine's broken.
you
know, someone
it's
stole
just,
it.
it's just going to be squares in there yet. Well, yeah, but it's just going to be squares in the circle. If anything, just
I'm just waiting for them to. No, you guys are good. I just want to wait until you guys get to a point where it's kind of making sense. All right, well, here we go. So again, if I want to find my volume, I need to integrate my area. So I'm going to do volume integral a to b of a of x dx, okay? Well, what is a of x? Well, it's just the area of a square. What's the area of a square? Base times height, or let's just do side squared, yeah? So we need to find an expression for s, which would be like the side length of one of those squares, okay? So again, I pointed out like this could be an example of s right here, like this line that goes from top to bottom here. So I need to come up with an expression for this blue line, okay? Because that's a side length. And again, I don't care about it at one specific x-axis. I need to write it, the side length, I need to express it as an equation in terms of x, because that way x could be anything, all right? Well, that depends on what this graph is. Like, what is this graph? Like, what is that function that represents this piece right here? How would I find that out? Max, you got your hand raised. How would I find that out?
Stretching.
Yeah, I know that.
What's stretching? I was looking at this. I was looking at the shape.
Okay, so like I need to find an expression for like this top function right here, right? Like this blue part, this curved blue part. How could I come up with a half circle? We could do that. So like I could take this piece right here, right? And then solve for y, right? Take the square root. Okay. So then if I do that, I get y equals plus or minus square root of 16 minus x squared. You guys cool with that? Solve for y by subtracting x squared, take the square root. I got plus or minus. So the top part is plus, and then Max is right, the bottom part is minus. So then this would be y equals negative square root of 16 minus x squared. All right, so then my length of it, my side length, please don't break that. It's all good. 16 minus x squared minus negative 16 minus x squared. You guys cool with that? So then we could just put a 2 in front. Right, because 1 minus negative 1 is 2. Okay, great. So there's an expression for our side length. So then now, if I go back to a, I get that a of x is just equal to that squared. The clicking now?
What shape is this supposed to be?
We'll take off one of those pieces and, like what is the name of that shape?
Well, yeah, like,
No idea.
so what's the point?
Maybe I wanted to make a security camera and it like that could look like a housing that could hold a security camera. So I need to design it in like a 3-dimensional software.
With a square cross section.
Well, like circular and then square, so I know how to house all those components. I don't know. Make it all sleek and cool looking. All right, but either way,
Cody doesn't want it, so
that's fine.
put it on Armand's desk.
Okay. All right, so if I square these pieces, I square the 2, I get a 4. And then if I square the part with the square root, that's just 16 minus x squared. So then that's going to be our expression for our area. So now to find my volume, I would then just need to integrate that. What are my bounds, by the way? -4 to 4. I didn't articulate this, but since our cross sections are taken perpendicular to the x-axis, that tells you which variable we should use to differentiate with respect to. So we're going to do with respect to x, because it's perpendicular to the x-axis. Okay. All right. So back down below. Now I do the thing. So can I just put that 4 in front? You guys cool with that? And then 16 minus x squared inside dx. And I don't need to square it again. I already squared it to get rid of the square root. So then I would just get 4, and then I would get 16x minus 1/3 x cubed. And then I want to evaluate that from -4 to 4. All right, so then 4, and then 16 times 4. I'm not going to go too fast. Minus 1/3 times 4 cubed minus 16 times -4. And then minus, no, that should be a positive 4 there. Sorry. No, that should be a -4. It should be negative. I'm so sorry. Okay, and then, so plug in -4. So then 16 times -4 minus 1/3 times -4 cubed. A lot of parentheses there. We okay with what I did though? Plugged in 4 and then subtract, plug in -4. Okay. All right, so then we do 4. 16 times 4 is 64. Minus 4 cubed, which is 64 over 3. And then minus negative 64 plus 64 over 3. All right, so 64 minus negative 7 would be 128. Minus negative 128. Or just 128 over 3. I think that's right. Okay, so then let's see. 250, so 4 times 256 over 3 gives us 1024 over 3. I might have did that part a little fast. But if you put, so you got to put 128 over 3, and you would get 512. No, is that right? 128 times 3. I think if we do 120, it's not 512. You said what? Yeah, I just couldn't remember the numbers in my head, but okay, yeah. But if you put this over 3, you get a common denominator and subtract 128. I just can't remember what what 128 plus 256 is. I just know 256 is the difference. But anyway, you should get 1024 over 3 units cubed. All right, that was squares. Let's do it again, but let's make our cross section semicircles. It's the same base, but coming off that are going to be semicircles. 1, 2, 3, 4.
Did you enjoy grading our tests on the break?
When did I do it? Sunday, right?
Or Sunday, yeah.
It was one of those days. It was fine. I can't remember how I had the opportunity to do that. My kids were out doing something, and I was like, I could clean the house or I could grade. Oops.
Yeah, when I went to do my homework, I didn't actually. I saw my grade and I was like, oh, I don't need to do homework.
Tessa! All right, so now coming off this are going to be semicircles instead. So again, I'm just going to, for sketch illustrative purposes, I'm just going to pick an arbitrary x value and say, okay, here's our base of our semicircle. We still have a flat circle on the bottom of our figure. And then coming off that is just going to be a semicircle. Okay? So the radius here in red is going to be this same radius there. I don't have a model of this one.
So, okay, this is the circle, and then make a semicircle off my circle.
So it's got like a flat
Like this.
circular bottom,
Yeah.
and then coming off of it are a bunch of semicircles.
Yeah,
Like, how does it matter where you're oval, like a potato?
Yeah,
I think it's
correct.
a potato.
Oh, like this line I drew in right here? Just arbitrary. I just wanted to
Does it
get.
look like a potato? I feel like it does.
I think it's just gonna look like
Or a sphere.
just like a half of a sphere, essentially.
Wait, so is it coming off of both sides?
Mm-hmm. Yep. Yep. If I did it here, it's gonna be pretty big. But yeah, it's just gonna create like a sphere, essentially. Half of a sphere, essentially.
This is the day in.
What'd you say?
Oh, wait, maybe, oh, those are the same.
Yes, I know.
All right, so step this out.
It's the same shape, right?
The whole thing's the day. I thought you did the red thing.
So our volume is going to be integral of our area. So the area of our cross section is a semicircle. So what is the area of a semicircle?
Square root of x squared.
1/2 pi r squared. You guys were a step ahead. You guys were doing the thing. But it's 1/2 pi r squared, right? Our radius is just going to be given by this red line right here from top to bottom. Okay? So I would have, whatever, we can make it pi over 2 instead of 1/2. But pi over 2, and then my radius is going to be just this red line from here to here, which we can use the same logic as last time, right? So I would just do square root of 16 minus x squared. And then it's pi over 2r squared, so then I would square that, of course. Okay? So if I take a second to actually simplify this a little bit, it would just be pi over 2 times quantity 16 minus x squared. And now we want to integrate that. My limits stay the same, -4 to 4, and then inside I would get 16 minus x squared quantity dx, and then I would integrate that. Cool, so let's do it. So then we would have, I'm just going to leave pi over 2 till the end, 16x minus 1/3 x cubed, and then that's going to be evaluated from -4 to 4. So then 16 times 4 minus 1/3 times 4 cubed minus, I'm going to write this one a little different. Try to get, instead of having too much parentheses. No cube there. 16 times -4 minus 1/3 times -4 cubed. Do you guys see how I wrote it where I put pi over 2, plugged in 4, minus pi over 2, plugged in -4? Now what I'm going to do is I'm going to factor out that pi over 2 and then combine what's inside of the parentheses in my one set of parentheses. Okay? So 16 times 4 is 64 again. And I would have minus a -64, so that's going to, again, give me 128. And then this would be, -64 over 3, and then I would be another -64 over 3, so minus 128 over 3. Okay, so again I would get pi over 2, 256 over 3. 256 divided by 2 is 128, so 128 pi over 3 units cubed. How we feeling? With those last two examples, do we have a rough idea of what's going on? Because the next example is going to kick the difficulty up a notch. But I have a model for it. So if we called it out, we're doing equilateral triangles. Could be.
Yes, it is.
128 pi over 3.
This one specifically.
That's 1/2 base times.
We're going to need that in a second, Max.
I'm picking up what you're putting down.
You smelling what I'm stepping in? Ugh.
I don't know that I like that one.
All right. What do you guys remember about equilateral triangles? Hopefully a lot. Hey, what's equal? Yeah. Hey, so here's one of my side lengths. Coming off of this circle are going to be a bunch of equilateral triangles. There's one of my side lengths right there, which means coming off that is going to be a triangle, which those two sides that I just drew would also be equal in length to that same diameter. So if I do that, flat circular bottom,
Really? There's two?
equilateral triangles coming off. You'll see. Well, so here's why this one's harder. Because area of a triangle is what? I got to come up with an expression for my base. Not a big deal, right? Here's my base. Coming up with my expression for the height is difficult, okay? And it's not too bad as long as you can remember your basic math facts from triangles.
Another cone on the other side.
There wouldn't be. It's flat. There is. It's. This is the exact volume. So sorry, Soph.
But you said that on the circle is coming towards us too.
Well, so like here's would be the dimension of it coming towards us. Would be like here. So like flat circular bottom, and then it's only coming towards us. That's it. It's not going out the
So
other
there is.
side. There's not a symmetric piece in
towards
there.
us?
So how do you
I
know-
asked
And then that's it.
I asked you earlier, and you said there was one coming towards us.
Which is that? So like this flat surface
Okay.
goes right here. Just become eyeball, and then the triangle just comes out. And that's it. Then it'll go out the other side.
How do you know it's coming in the
Will it come
positive
out to the
direction?
other side or no?
No. Like there's no set. This isn't like half of the figure.
Oh. Okay.
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 Mr. Pacifico, how do you know it's coming this way and not that way?
Could be doing either one, but we just.
But wouldn't it be like negative if we're going the other way? How do you know it's not?
Yeah, I guess. So that's how I know it's coming towards me. I guess. Positive version of it. It's telling you that this is. Here's why. I know it, because it's telling you. Like I said, your name is way. But here's how I know it.
Wait. Pay
Hold on a
attention.
second. This is the base of your solid, and it's being built on that base.
Oh, so is this the ground?
Okay, yeah.
This is the ground.
Yeah.
Okay. That makes sense.
Okay. Yeah,
Approved.
that was helpful.
All right, cool. Pass that bottle around the way, everyone can see it. Where's my iPad? All right. Don't be. All right, so now what I want to do is I need to, let's do it. So, all right, integral of a to b, a of x dx. Okay, so, all right, so we said 1/2 base times height. We got to come up with an expression for those, okay? You guys with me? The base of my triangle is on that graph there. That's no big deal. We're just going to use the same as the, like the squares. It's going to be the same as the side length for the squares. It's just coming up with the height of that triangle, which is a little difficult. So I'm going to draw one of my triangles right here. The best of my ability. All right, so this is my base, okay? Now, I need to come up with the height of that.
Is it side triangle? SOHCAHTOA?
We don't have to use SOHCAHTOA, fortunately. Throwing trig into this would be a bit wild. We don't have to use SOHCAHTOA, though, fortunately. What else could we use? What else could help us out here?
Oh, the
45 2 angles.
no, that's
It's half your base
You cut the
square
triangle in half
plus
your base.
half
Yeah,
your square plus that height.
That question said what she said.
What'd you say? Yeah, Rohan's right.
You cut the triangle in half. And
Okay?
then you have one side like 2 and a 4. Like, oh yeah. The right angle, the square root stuff.
Rohan's the only one who I think has got it so far.
Rohan, share the class.
You guys literally got it.
I think they did. I think they did. But they threw a 4 in there. Why'd you throw the 4 in there?
You have to find the
It's
height
okay.
of it.
Yeah, so like the base, can we all agree that like the length of the whole base here is 2 square root of 16 minus x squared? Are we cool with that? So then half of that, so just this piece right here would just be the square root of 16 minus x squared. That'd be like from here to here, yeah? But how would I find my height?
It's a right triangle.
What type of right triangle is it?
30, 60, 90.
Yes. It's equilateral, so it's equiangular. So all my angles are 60 degrees. So if that's the case, my short side is square root of 16 minus x squared. What would be my long leg? It'd be square root of 3 times the length of my short leg, which is 16 minus x squared. My hypotenuse would be 2 times square root of 16 minus x squared. Okay? Which should make sense because it's an equilateral triangle, and that's what we said the base of that triangle was for the big triangle. Okay? All right. You with me? Okay. All right, so a of x equals 1/2 expression for our base, which is 2 square root of 16 minus x squared times our height, which is square root of 3 times square root of 16 minus x squared. Which actually shakes out really nicely, because if I start simplifying things, my half and my 2 cancel out, cool. But then my square roots would multiply and are no longer square roots. So I would have square root of 3 times quantity, 16 minus x squared, instead of that being in a square root. So that's the expression for my area. So it actually shakes out really nicely, but the setup is a bit wild because you have to step back in time to 8th grade.
So can we just like memorize that, like for an equilateral triangle, you just do 33 times whatever the base is?
Would not recommend it. Would not recommend it. I need you to know how to build it.
Oh, okay, cool.
Building engineers here. What'd you say?
Most of the time would it just be that?
All right. So our limits, so I'm just not going to give an answer. -4 to 4. Okay. The square root of 3 I'm going to put out in front. And then I'm just going to integrate 16 minus x squared dx. Okay. Square root of 3. 16x minus 1/3 x cubed. Evaluated from -4 to 4. You guys are chatty today. God. I can't even focus. If I can't focus, then that's like, it's an issue. All right, let's plug in 4 and let's plug in -4. So 16 times 4 minus 1/3 times 4 cubed minus square root of 3 again. I'm going to do the same thing I did last time. 16 times -4 minus 1/3 times -4 cubed. We know that story pretty well already. So if I combine inside the parentheses, I think I get something like this again, where 16 times 4 is 64, and then we would add another 64 to get 128, and then same thing with -128 over 3. So then we would get 250, nope, my brain got ahead of itself there, 256 square root of 3 over 3 would be our final answer. By the way, that's an answer I want to see on the quiz, not a decimal. If absolutely necessary, give me a decimal answer. Like if you're taking the quiz and you get to like this point right here and you're like, bro, I don't know, give me a decimal answer. But then if you want full credit for the problem, go back and get me the fractional answer. Okay? All right. Questions there? Okay. Oh, man, I don't even know if I have time to do example. We're going to do it. All right, here we go. Find the volume of a pyramid with a square base a by a and a height of h. Okay. Pyramids. So essentially what I want to do is like, let's build a pyramid real quick. Yeah, it didn't take the ancients a long time to do it, so we can do it. I don't know, I'd love to. All right, here's our pyramid. I need to find the volume of that bad boy. Do you guys remember how to find the volume of a pyramid? 1/3 area of the base times the height, right? So 1/3 a squared times our height is our target answer. It's what I want to end up with, okay? But what I need to do in order to get it, in order to do calculus, in order to find it, let's put this on an x, y axis. So I'm going to do it, maybe it's a little bit of a leap, but we're going to do it here. What I'm going to imagine is I'm going to say that, like, I'm going to put my y-axis here. So this is going to be my y-axis, except it's going to be a straight line. I'm going to put my y-axis here. And then I'm going to put my x-axis kind of emanating through the center of it here. So this is going to be my x-axis. Okay? So that means I'm going to rotate it up this way. And it's going to look like this. Here's going to be that same center point that's right here. And then, oh man, I'm going to do my best here, guys. Bro's right. Okay. Something like this. There it is. If I use the same logic and I need to integrate my area, what is the area of my cross section? Like if I slice down here, it's going to be a square. So I need to take the integral of the square. Now, they didn't give me any numbers. They just gave me letters. So I have A by A are the dimensions of my square base, and my height is H. So where's H going to come in? Yeah, it's that point all the way here. So here is a distance of H, because that's like the height of my pyramid, okay? Now, as far as A goes, the length from here to here is A, okay? So what I'm going to do is I need to do like top minus bottom when I do like some sort of rectangle in here. So I need to come up with an expression for the top and expression for the bottom. So I'm connecting it to this line right here. Sorry, I tried to bolden it. And this line down here. But those are exactly what I just said. It's a line, right?
Is equal to positive, negative, volume 0?
No. Yeah, because I'm going to do, like I'm building like a three-dimensional volume. I'm not going to work with, it's going to be a positive value here. All right, but either way, I need to, hold on, my brain is rebooting. It takes a second for that to happen sometimes. Okay, so I need to build an equation for that line, okay? So it's just y equals mx plus b. What's my y-intercept, though? It's just, I'm passing through the origin. It's just going to be 0. So I need to come up with a slope of the line, okay? So like, let's say I'm finding this point right here, okay? So what is my rise and what is my run? So my run would be h. You guys agree? So what would be my rise? Good. So we're going to do a over 2. Hold on. So 1/2 a, or a over 2, over my run, which is h, times x. So that's like y equals mx, right? Because it's the equation of my line. So I could also write this as y equals a over 2h times x. There's the equation of my line. Now when I do that, and I subtract it from the bottom, wouldn't the bottom be the exact same thing, just negative? So then when I do my area of my square, so area is just going to be side squared, would you guys agree that I would just have to do a over 2hx minus negative a over 2hx? I would just double it, right? I'll write it the long way. So a over 2hx, so that would be the top part. And then minus the bottom part would be minus negative a over 2hx squared. But it's just adding the same thing, so I would double it. So I would just eliminate the 2 that's on the inside. Would you guys agree? So I would just get a over hx quantity squared. All right, so my volume is going to be the integral from, what are my limits of my integral? You said what?
0 to a.
Not negative a to a, not 0 to a, but you're closer, 0 to h. And then I would just do that expression squared. But I'm going to write it as a squared over h squared times x squared dx. All right, a squared over h squared, I can just toss out in front because they're constants. X is my variable of integration. So then that's just going to be times 1/3 x cubed. And then I'm going to evaluate that from 0 to h. The good news is when I plug in 0, I get 0. So otherwise I get a squared over h squared times 1/3 h cubed. The square and the cube cancel out, and I would just get 1/3 a squared times h, which is what Rohan told us the volume of our pyramid was.
Good job, Rohan.
I had to go fast there at the end because of timing. Sorry. We also didn't get to the tests.
Told you that's what happened.
I got to stop talking to you guys and just start teaching. I think that's what I'm going to do. And then you guys got to keep side conversations to a minimum, and then we'll just go through it. That's what we'll do. No longer am I going to talk to you guys. We're just going to do math. That's it. Your homework's on the last slide. Have a great day.